Now, without further ado, let me introduce the first speaker to you. His name is Robin. He's very passionate about software and very eager to try out new technologies, one of which he will now tell you more. Please give him a warm applause via the chat, and the stream is all yours, Robin.
Right, thank you very much, Paco. Welcome all, thanks for joining this talk. I'm going to tell you about how I build a platform native CLI with the technologies mentioned over here, which are Kotlin, Clikt and GraalVM. So let me first introduce myself. So my name is Robin Trietsch. I'm a software engineer at OpenValue. Currently, I'm building a stream machine. I'm helping to build an event processing platform that focuses on privacy and data integrity. I mostly work with the JVM, with the JVM languages such as Java and Kotlin, and with the data engineering stack. So think of Kafka, for example. And well, I'm always looking for new tech to try out, and that's also how I decided to try out GraalVM, which is a key component here in this talk. So well, let me first tell you something about the Stream Machine. I already told you what the focus is of Stream Machine. And well, Stream Machine has a public API, and well, this public API, of course, has an open API specification, and well, this allows us to generate a nice Swagger page for customers to interact with. However, it's not really straightforward to use the API, because you need to do some steps. Most of the endpoints are protected with some authentication. So first you need to authenticate with Stream Machine, and well, the next steps is actually to use these APIs. However, we felt the need to give customers a better tool to actually use these APIs and interact with Stream Machine. So, well, that's how we came up with the idea to create a CLI. Stream Machine also has a front end, a portal. However, this portal, you know, as all front ends do, they require a lot of attention to show all the features that a product is capable of doing, and therefore, as we're only backend developers yet, we decided to go with a CLI, because that allows us for well, quickly actually exposing features to customers. So that brings me to the need for building a command line interface. As I already said, it's quick and easy to develop. As a backend engineer, you only when you have a new endpoint, you add a new command to the CLI, and it's directly ready to use. The CLI can be very feature rich. It can do a lot of complex commands, and also do all the handling of authentication. And also pretty important is the option to do auto-completion. As APIs can grow very large, it's really nice to have something as autocomplete, because then you don't have to remember what the API looks like, all the options that the API offers, because the CLI can explain it to you. So let me state the goal and the problems that we had here. So the goal was to build a multi-platform rich command line interface with autocomplete options. And we faced actually the following problems. So the first one was the language of choice. The second one was the framework or library that we were going to use for parsing arguments. The third one, creating a platform native binary, because you want to run it as standalone. You don't want to be dependent on other dependencies that should be installed on the platform that you're running it on. And the fourth issue is actually cross or multi-platform builds. So ensuring that these native binaries run on every large platform. So let me go to the first issue. So the language. As I write a lot of Java and Kotlin, those languages, well, they first popped up, of course. However, when writing a command line interface, you often think about Python, for example, but also Golang. A command line interface that that is written in Python is, for example, the Google Cloud command line interface. And Golang is also very popular because of the libraries that Golang offers for parsing command line arguments. However, we decided not to go for Python because you need to have Python installed. And of course, it's installed on most platforms. We decided not to go for Golang because we didn't have a lot of experience writing Golang yet. So that left us with the JVM languages. Well, then it's an easy choice for me. I like writing Kotlin because it's much more concise than Java. So that's how we came up with writing it in Kotlin. That brings us to the CLI library or framework, if you would like to call it like that. There are two major ones that can be used with Kotlin, which are Pico CLI. Pico CLI is annotation based, and well, it's very extensive. You can do a lot with Pico CLI. However, because Clikt is native for Kotlin and has a very nice DSL for Kotlin, we decided to go for Clikt. Pico CLI also has this list of command line interface library comparisons, and the link is listed below. There are listed dozens of libraries and frameworks. So that brings us to the third one, native binaries. Well, for the JVM, I only know of one, and that's GraalVM. So that's an easy choice. Well, then the fourth issue, cross-platform builds. There we have multiple options. The first one is doing it by hand. GraalVM doesn't offer a cross-platform compilation out of the box. Actually, when you want to compile a binary for a macOS machine, then you have to build it on a macOS machine. Same applies for Windows, same applies for Linux and Unix. So if you do it by hand, then you need all of these machines. Well, the first thing that pops up then is doing it in virtual machines. However, you also need to manage these virtual machines then. And what's better than managing virtual machines yourself? Let somebody else do it. So that's where GitHub Actions comes into play. GitHub Actions offers different machine types to actually execute parts of a CI pipeline, and that's how it allows to choose a certain platform. So GitHub Actions was the choice there. Well, if you want to go this way, then you have a few prerequisites. The first one is having GraalVM installed, of course. The version that I've got installed is 23.0 R11. R11 stands for Java 11 here. If you would like to use Java 8 for some reason, then you can go with R8. The second one is installing the native image GraalVM component for actually doing the compilation of your application to a native binary. So I talked about Stream Machine, and I would like to see if you can guess this. Which other everyday product needs a CLI? So Paco, can you help out here? See if people say something.
Yes, if you have any answer, please put them on the chat. There's still.
Let's give it 15 seconds.
Okay. It's still.
No comments. All right. Well,
Comments.
It's probably the delay. Let's keep it at the delay. All right. I'll just give it away. It's Spotify, of course.
Oh, sorry. The cooker was an answer.
Oh, cooker. That's also a good one. Well, I decided to build a CLI for Spotify with these technologies because Spotify is an everyday product that a lot of people are using and are familiar with. And how cool would it be if we would have the option to just type in our terminal that our Spotify should start playing? That's way easier than using the actual application for your desktop, of course. So let's continue to the demo. So I'll be showing how to set up a Spotify application. That involves going to the Spotify developer dashboard. Next, I'll show how the CLI authenticates to Spotify. I'll be showing how to store the access token. And the last one, the best part, of course, is controlling the playback of Spotify. So let me go out of here. Let's first go to the developer dashboard. So if you log into the developer dashboard, let's see if I'm still logged in. Yeah. Then you'll be shown, if you don't have any apps, this will be empty. I already created one for the CLI, but if you want to create an app over here. So say my awesome CLI. Click the two checkboxes and create. So we have this, you will get a client ID and you can show the client secret and copy it. Take note of these because we will be needing these later. One more important thing, because we'll be doing an OAuth authorization code flow, go to the settings and add a redirect URI. So this will be my redirect URI over here. And of course, you can add more if you want. But as the CLI is always running on your machine, it will always be localhost as the redirect URI. So I will be talking to the Spotify API using this Spotify web API for Java, which of course can also be used in Kotlin. And this is a very easy way to interact with the Spotify web API. Let me go to the code. So as you can see, this is a simple Maven project. And this Maven project has the following dependencies. We'll be using Clikt. So that's CLI KT. We have some dependency to print color text to our CLI, GraalVM dependency, Kotlin standard lib. I'm using Hokon configuration files over here for some config of our CLI, the Spotify web API, and the servlet, JavaX servlet API, and Jetty servlet for the OAuth callback. So let me actually go to the code. So the main entry point here is, actually just the main method, and the arguments are parsed to the Spot class, an instance of Spot class. I'll be going there in a second. And Clikt does the parsing of the arguments actually for us over here. If we look at the Spot class, you extend Clikt command. And the next thing that's important is that you override the run method. The run method can either do nothing or it can do something. It can do nothing in case this is a parent command that has only subcommands and you don't want to invoke anything when it's called. And if it does something, well, then that's the command that is executed. This root command, which is called spot, consists of 3 other commands. And I'll be taking a look at the account command first. So as you can see, the account command is also a Clikt command. That's the structure that you follow all the time. And as you can see over here, this run command actually does nothing. If I go to the who am I command, then you see that this is actually doing something. So it uses the Spotify API, calls for the current user's profile, executes. So there it actually calls the Spotify API. And then if we get a user return, well, then we print this text to the console. However, you see over here that it's wrapped into a run if authenticated. That's a convenience method that I made for just passing along a lambda that will be executed, but only if in certain cases. So as you can see, we need credentials because, of course, we need to authenticate ourselves to Spotify, and we actually need to have valid credentials to do the call. So say, for instance, that we don't have any credentials. Well, this will return a null, and then we'll end up over here, and it will state that I'm currently not logged in. I also print the instructions on how to actually get a valid token. If we do have credentials, well, then it executes the block, and if it fails, then it will check if the credentials are expired or if it's an unexpected error. So let me go to the get credentials method. So the get credentials method, it actually has a credentials field that is wrapped into a object. This object is a context for the CLI to operate in. I noticed that this is the easiest way when writing a CLI this way, to have a shared context that can be called from anywhere within the CLI, because you need these credentials everywhere. And the same applies, for example, for the Spotify API. The Spotify API you also need everywhere. So let me go back to the get credentials method. Here we try to read the credentials, and we try to read the credentials from disk. Well, why from disk? Because every action you do in the CLI is a separate run of your application. You should see it as standalone. Well, within the run of your application, you have state, but in between you don't. So every run starts with a clean slate. And that's why if we have credentials, we actually need to persist it on disk and actually read it every time we want to execute a command. That's why we take these credentials from disk, and these credentials are stored in the authentication flow that I'll be showing later on. So this credentials file, I just take the user's home and put it in a directory over there, and I write it to credentials.json. So let me actually go back to the root command, so to spot, and let me show you what authentication looks like. So authentication has 2 subcommands, login and revoke. Revoke is pretty easy. It just removes the credentials file. So it's like a clean slate that you have to re-log in. If I go to the login flow, then upon login, I first start a callback server. This is just a Jetty server. And next, I actually build the authorization code URI with the respective scopes. Don't look at the scopes because they're very wide. That was just the easiest way over here. I'm not using all the scopes, but if you want to fork this project and continue building it, look at the scopes. For convenience, I also print the URI to inform the user to go there, and we try to open the URL in the browser. But if it doesn't work, then you always have the URI printed next to you. Well, then we wait for the server to have a response. Why do we do this way? If I go to start the callback, then you see how it started over there. And if we look at the servlet, it waits for receiving the code. And when we receive the code, we assign it in our CLI context. And next, we stop the callback from there because we don't need it anymore. So that's why we can do a join over here. Well, then we can call the Spotify API with our code and then actually get client credentials. And the last part, we store the client credentials on disk, as I said before. I will actually show you what that looks like. So I already have this binary compiled and on my path. So that's why I can actually do it this way. So as you can see, I also have autocomplete. I'll show you later on how that's done. So let me go to auth, login. So this is the Spotify consent. It shows the name that I gave over here to the CLI. So that's the same name over there, and all the all the scopes that I requested. So let me say okay. Well, it prints that I'm successfully logged in. Return to the terminal to actually start using the Spotify CLI. So what does it look like? It should have stored a credentials file over here. So let me only print the first 50 characters because it's an access token. And as you can see, it actually did write a file over there. So now we should be able to start using this access token to actually do commands. So I already showed you the account who am I command. Let me see. Yeah, well, it knows who I am. Well, that's great. And it's actually correct as well. So you already saw the other command, playback. Let me first show you what it looks like. Let me go to the root command, then to playback. So playback consists of the following subcommands. We have a play and pause. It can show what's currently playing, and also the devices that I'm able to play music on. So the Spotify API requires when you start playing music that you specify the device that you want to play music on. So let me first go to the devices command. And this devices command consists out of two parts, listing devices and setting a default device. Listing devices, well, pretty straightforward. Just ask for the user available devices and print them to the console. With set devices, it's a bit more complex because we want to have a completion option for this command. And here you see that I'm actually using something from Clikt, which is parsing arguments. So I'm requesting an argument with the name. I'm specifying the help text that should be displayed, and also showing completion candidates. So these completion candidates are actually invoked from a standard out by invoking another command, and that's actually spot playback devices list. So that's actually this command that I'm invoking over there to do the autocomplete. Let me also show you what the help looks like. So this is what is printed to console if you specify help. And as you saw before, you also have autocomplete options, and that also works with options and with flags. So we have autocomplete for this name, for the device name, and what we actually do here is verifying whether the name specified by the user is actually existent. If it exists, then we print it, or we actually print that we set the device, but we also actually store it in a preferences file. So if I list the this directory, I only have credentials right now, and I actually have to set the default device. So let me first list them. There you go. Well, that's this machine. Set the device, and as you saw, I pressed tab and it auto-completed to this machine. Set it, and if I list it now I have a preferences file, and actually, I'm not storing the name of the device here, but the device ID, and that's also why I'm not printing it completely, because it's device ID. But I've got the default playback device ID saved here. So now I actually should be able to start playing music. So let's start. Right? What is it playing? The show command shows what I'm actually playing. Feeling Me by, okay. Oh, it's correct. So it's the song in me. Let's actually pause it. Well, there we go. We controlled our Spotify through the CLI. All right. I already said at the beginning that you should take note of the client ID and client secret. Actually, I briefly showed it to you. So let me go to the context. But the magic is done over here. We provide the client ID and client secret. These are actually taken from a config, and this config is provided by typesafe config, which is a great library for reading HOCON configuration files. And I'm parsing it here into a data class for convenience. So I specify the client ID and client secret here, as well as the callback, and the port and path are also coming from the configuration file. Well, that's actually that part. Now to the part where we build a native image. The native image, I have GraalVM and the native image component installed. And with the native image plugin, you can actually invoke it from Maven. So you can bind it to a specific execution goal. And well, that helps for just executing your standard Maven commands to actually build the native image. Well, you see a lot of flags or options over here. I don't know what all the flags mean. Some flags are required, and you just do some trial and error to figure out which ones ensure that your build works. So it might be possible that not all of them are required over here. But the ones that are required, well, HTTP and HTTPS, of course. HTTP because we're talking to localhost, and HTTPS because we're talking to the Spotify API. These ones are also very important. Initialized at build time. So these packages are ensured that they are initialized at build time. This was the first time that I actually needed this. That's because this is an OAuth authorization code flow. Therefore, I needed Jetty and a servlet to run. And these require to be initialized at build time. One last thing, I want to include the resources. So the resources that I have over here are actually these configuration files. These are required for reading them into our CLI configuration class. Then a last thing that's very important, which is the reflection configuration. The reflection configuration is very important for GraalVM because you need to instruct GraalVM what classes look like, which objects or which fields do they have, and how GraalVM should interact with these classes and objects. If I show this file, you see that it's a pretty large file, this is what can really bite you when you start using GraalVM. You really have to instruct it how to work with objects. This really comes into play when using libraries such as Jackson and JSON, which really use reflection. So if your build fails, or if it fails at runtime, actually when using the binary that you compiled, first think of reflection, because that's one of the first starting points. That brings me to the last part, the cross-platform builds. So I can do a platform build on my machine, which is macOS, but I still want to build binaries for other platforms. So that's where the GitHub Actions workflows come into play. So here we have our CLI release pipeline. It consists actually of two steps. The first step is building the jar. And the second step, which is done in parallel for 3 different machine types, is actually compiling the native image binary. So we ensure that we build the jar, upload it to GitHub artifacts, and these artifacts will be actually downloaded again in the next step to actually do the compilation. So here you see building non-Windows images. So with Ubuntu latest and macOS latest, here you see the native image command being invoked with all the arguments. It's a bit different from the arguments that I specified in the POM. And also the Windows build. Here it installs a lot of things before you can actually start compiling the native image. But in the end, the goal is the same. It compiles the native image and uploads it to a release. Let me show you what it looks like when going to the actions. So if we go to releases, I configured it so that on every tag, it will start executing the GitHub action. So here you see the release with the Linux, Mac, and the jar. You see that the Windows image is missing. Somehow, I don't know exactly why, but somewhere since last week, the Windows build is failing due to a dependency not being able to be installed. So if I go to the actions, you actually see that it fails, but it failed partially because the Windows build is failing over here. But here you see the 2 steps actually. So building the jar, compiling the images for the different platforms. Well, that's actually it. So let's go back to the presentation. So some caveats. As I already said, reflection is not out of the box for GraalVM. It's really something to think about. By the way, there are tools available, like I think it's a Maven plugin that you can use to actually generate these reflection files so that you don't have to write them yourself manually. Well, as I just shown, the Windows build broke. Yeah, I don't know exactly why. I don't have a Windows machine here, so I can't really figure it out. But yeah, think of that. You have an external dependency on a platform, and builds can break unexpectedly. And also something already said, but sharing state between several CLI commands, you really have to think of the fact that your CLI, that every command is a separate run of your application. So that's something to think about. That wraps it up. You can try it yourself. Go to this URL, and you can follow the README to start, fork the project, create your own CLI, use it any way you want. And another example, of course, this is all based on the CLI that we made for Stream Machine. So feel free to also check out that page, github.com/streammachine.io/CLI. Or if you want to learn more about Stream Machine, go to strm.in. That wraps it up for me. Thanks for watching. And I think this is the time for questions.
Yes, Rowan, thank you for your presentation. I really loved the CLI case you took. It's a fun way to learn new technologies. For the people watching, please put your questions if you have any in the chat. We already had one. The first one was whether the code will be available on whether the code will be available, but I see the link is already on the slides, so that's nice. It's also in the YouTube channel chat. And the second question is, are you sorry, there it is. Yeah, whether the file is stored in your machine in plain, and we're talking about the Spotify access token.
Yeah. For now, that's indeed stored as plain text. Yeah, I'm just using JSON here to store it on disk. Yeah, while writing the file, of course, we should set some permissions on the file so that not everyone has the option to read it. Any more questions, Paco?
I currently don't see any coming by in the chat, but I do have one myself. Actually, was it a lot of work to create this Spotify CLI? And is there good documentation on the API?
Yeah, the documentation is actually pretty good. I already knew of the web API. They have very good API docs. However, with this API client, it's really trivial because you can just look at the method names and you know how you can use it. So I think the most work of building this CLI was actually building the OAuth flow, because starting a Jelly server and a servlet inside a native binary, well, that involved some work, and that's why I said look at the reflection config, because I really had to look at the reflection config over there.
Okay, well, I don't see any more questions, but if people still have any questions or come up with them later, they can also reach you on Twitter. I see it's also in the slide as well, at Robin Trietsch. And that's it, I think. Thank you again for this awesome talk. We'll be